minus 3 sigma, and requirement, which is plus or minus 6 sigma. We would also look at some deeper component of this in other slides of this presentation. So yeah, we've discussed Lean and we've discussed Six Sigma, but both of them are the same tool. Both of them are tools used to drive continuous improvement. So what's the difference? What's the slight difference between the two of them? The Lean focuses on waste reduction, like I mentioned earlier, whereas Six Sigma emphasizes variation reduction. So in Lean, we're looking at the process, you're looking at what activities are not adding value to the system that you can remove. While in Six Sigma, you're looking at the capability or the ability of the process to deliver with minimum variation. So Six Sigma is variation reduction, while Lean is looking at waste reduction. And then Lean achieves its goal by using less technical tools. So you see in Lean, you see tools like Kaizen, workplace organization, visual management, or visual control. But when we get to Six Sigma, you see a lot more focus on statistics. Six Sigma uses statistical data and analysis. You also have design of experiments, and then hypothesis testing. These are the tools, statistical data, that Six Sigma uses to reduce variation in the process. Also, just to give much more closer view into the difference. If you look at the goal of Lean, as earlier explained, is to reduce waste and improve the process flow. But for Six Sigma wants to reduce variation. It wants to improve the capability of the system. Now, when we talk about system capability, usually when you have a process or a system design, there is a target that is given for the system. So if you want something to produce, or you want a particular target to be attained, Six Sigma helps to ensure that every time you do that process, you are getting, the process is able to deliver that target you have set for the process. Now, so in Lean, you would focus on flow, you focus on speed, you focus on time. Lean is how fast can I get it done? How much more can I produce in this time? But Six Sigma is saying that, oh, in this time of producing, how can I make sure that my defect level is reduced? How can I ensure that variation in the process is reduced? And then if you look at the tools both of them employ, like I mentioned earlier, while Lean will be using tools like Kaizen, 7 Waste, and Gemba, that's visiting the place where it's happening. In Six Sigma, you will be hearing tools like control chart, which helps you set the target and set the upper and lower specification limit. You'll be looking at gauge R&R, which is repeatability and reproducibility, where you are able to say that if different people are testing, if different people are using different tools to test, how can we ensure that there is a minimum variation in the result both of them are generating? And of course, the big part of Six Sigma would be statistical process control, which is explained better in other slides. Now, when you combine Lean and Six Sigma, what do you get? You get speed and accuracy. So it means that I'm able to deliver this faster, yet I'm delivering on target. I'm delivering on target in a faster time. So that's why we say, you see, speed plus accuracy is what Lean Six Sigma gives you. Now, what then is Lean Six Sigma? Over the years, the gap between Lean and Six Sigma has narrowed to some extent, where we now have a single word sometimes that can then be used to explain or describe the two, and that's Lean Six Sigma. So if you see, Lean Six Sigma is defined as a fact-based, data-driven philosophy of improvement that values defect prevention over defect detection. So we are not just detecting errors, we are not just detecting variation in the process, we are also preventing. Prevention is key in Lean Six Sigma. And customers are the center of this. So it drives customer satisfaction and bottom line result by reducing variation, it reduces waste, cycle time is reduced, and you have a competitive advantage because in using Lean Six Sigma, you are able to reduce the cost of your production. And just to be clear, it applies anywhere variation and waste exist. And every employee must be involved. So when you say Lean Six Sigma, it's not something you apply to a particular process or this process. It can be applied in any process, any. In fact, I like to say that you can apply Lean in your personal life. When we start looking at some of the tools, you see that even for your personal life or the things you want to do yourself, you are able to apply the tools that you use in Lean and in Six Sigma for yourself. Now, before we go into the overview of the Six Sigma certification roadmap, we first need to look a little at Lean and Six Sigma. Last week, we spent a lot of time explaining and describing Lean, so I would just be going through some additional reference material for Lean while spending more time on the Six Sigma aspect. And what the idea of this section is that you need to understand that Lean understanding is part of the required knowledge to effectively achieve Six Sigma. So if I'm going to be achieving Six Sigma, I must have good understanding of Lean. So let's go. Now, we're going to be looking at discussing the Lean concept, principles, and tools. There is this part where sometimes we think that Lean is a different methodology. No, Lean is a thinking, is a philosophy. It's the way to go. When you establish Lean processes, when you are able to eliminate waste, when you're able to ensure that the process has been reduced to remove all forms of non-value adding activity, it must be a thinking. As I'm working, I'm looking at this activity I'm doing. Am I able to, if I don't do this, will I still be able to meet customer satisfaction? Will customer be able to pay for this? So it's a way of thinking. You're thinking it. And then Lean also, we use the PDCA cycle. I have it somewhere later in the slide, where in establishing Lean, you use a continuous improvement method where you plan, you do, you check, and you act or adjust. And then you go over the cycle again. And each person also, in Lean, each person are assigned role. You must know your Lean role. So you have people in the team that their contribution to achieving a Lean system is clear to them. And it also helps us, one of the things it helps us to do is you now start looking at the customer. You put the customer at the center of what you're doing. Because the customer, in Lean and Six Sigma, we recognize that the customer determines the process of what we are doing. Why am I in business? I'm in business because the customer expects this from me. And if the customer expects that from me, I must put the customer at the center of my process. So you are looking at the customer. Does this add value to the customer? Are there better ways I can do and get the customer requirement? So that's one of the things it also helps us to do. And then it gives us an idea of what an ideal process should look like. An ideal process is a process that has been fully optimized to eliminate every form of waste. A process that has been fully optimized to eliminate every form of waste. So you have over time continuously improve and say, okay, at this point, every activity, every resources that is being used in this system or in this process is able or is directly related to the customer requirement, and they are all value adding. So that's just some of the things Lean principles and concepts helps us to do. Then Lean simplifies our work. It helps you to organize your work area. It makes things easy. You know, sometimes we like to use the word keep it simple. Lean helps you to keep it simple. And you can find out tasks that you see are repetitive tasks, and Lean helps you to automate it. You put a system in place that can ensure that that task is done consistently and on target. And we've been using value-added and non-value-added activities. So what are the definitions of these two words? A value-adding activity, an activity is value-adding if the customer is willing to pay for it. So if a customer is willing to pay for it, it is value-adding. If it will transform a product or a service, then it is value-adding. If it can be done correctly the first time, then it is also considered value-adding. So That is important. You must have that while working in every aspect. We must have that at the back of our mind, that you must know the tasks, the activity that are value adding. Then we have non-value added activities. These are activities that will consume your result without creating value for the customer. Okay, let me use an example here. In a baking industry, when cakes are supplied to you, the cake would come with a board and would be in a pack. Now, if you have the cake in a box and in a pack, but you as a customer, what have you paid for? What you paid for is the cake. So if I, as a producer, can see a way I can reduce cost in the pack of the case or in the cake board, because it is not adding value to the customer. If I am able to reduce or to eliminate and find alternative that can still deliver the cake to you in the form where you are able to present it and use it, yet I am not spending on those other additions, you can see that I have been able to, yes, still remove a process that is not value adding. Now, yes, you can say, okay, because the cost that for me to be able to carry it around, for me to be able to, but you must remember that we come from the thinking of, is the customer willing to pay for it? So that is critical. That's important. Then, you know, if a tax is also non-value adding, if you see that low percentage of the time, the work is, your percentage completion is low. The defect rate is high. Defect rate is high. If I finish the process, maybe 50% are good, 50% are bad. So you need to also look at that. It's important. That's another thing that you see. Those activities are then not value adding. Then if you see a task that requires extra effort or resources without necessarily adding to the bottom line, then it is also non-value added. So it's critical to be able, in implementing Lean in Six Sigma, it's critical to be able to identify these two tasks. We also clearly, Lean is not an acronym. It's a philosophy, a thinking, a process. It is not an acronym. It's not a diet, obviously. It's not talking about how you would lose weight. No. Lean is not looking at your BMI index. In fact, rather, Lean is looking at your process BMI index. If you consider it that way, you look at it and be like, okay, so if my process is lean, it means it's not overweight. I don't have extra non-value added activity. So you look at it that way. So it's not a diet for a human, but it's for the process. And Lean, one of the biggest concerns about Lean is that people think that when you want to implement Lean, you want to reduce head count. Not necessarily. It's not an initiative to reduce head count at all. First, Lean looks at the process. So we'll be looking at, later you'll see how and where Lean and Six Sigma comes in the CPOC chart. So it's looking at this process, and it does not replace Six Sigma. It cannot replace Six Sigma. They are complementary. They are complementary. And it's not a manufacturing thing. Some people believe that you do Lean only in manufacturing industry. No, you can do Lean in service industries. Lean is involved in human resources. Different aspects of business can implement Lean, because Lean does not require any special expertise. There is no special expertise required. It's just the basic knowledge of the process and ability to be able to define the value-adding activities and out. Yeah? Okay, so we've been saying that Lean focuses on the process, but why? Why the process? 85% of all improvement opportunities are in the process. Last week, Tijani, which I think you can please avail yourself the opportunity to go to the YouTube page and download and watch Tijani's, Engineer Tijani's teaching on Lean. Last week, Tijani helped us to understand that, unlike right now, in the conventional method of when I want to make more profit, I increase price, is no longer working. People are not willing to pay much more. And so if you want to improve your bottom line, you can't improve the bottom line by increasing price. Again, one of the best and easiest way to increase your bottom line is to reduce the cost of your production. How can you reduce the cost of your production? You focus on your process. You focus on the process. You look at the process end to end and remove resources, activities you don't need to do. Now, you would have seen a lot of companies are doing lightweighting, reduction in size. Many of all of those activities has to reduce production cost. You reduce your production cost and keep the price constant. What happens to the bottom line? The bottom lines improve. So that's why we say 85%, you focus on the process. I also like one of the father of continuous improvement, Edward Deming. He said a good process will beat a bad process will beat a good person anytime. So if the process is bad, no matter how good the person is, it's going to beat him. And so this chart, yeah, I have called out the lean principles. What principles do we focus on in lean? You know, like I said before, it's customer focused. You must focus on the customer. Then you have data-driven decision, where every decision you are taking is done taking into consideration the numbers. You verify data with anecdote with data. A good example is when you see, for instance, somebody in your process, anytime you ask to identify root cause, everybody naturally comes up and mentions a particular root cause. You have a responsibility to subject that to data, because data is key to help you drive improvement. Then we talk about result, accountability, and excellence. Excellence in the sense that at the end of every lean project implemented, you must have standardized this to achieve excellence. So excellence is critical as a lean principle. And I've called out some of the, here we have a lot of continuous improvement lean tools. So Kaizen, of course, Kaizen, like from the original word, is little improvement that is being done on the process. Also, sometimes we use Kaizen as a form of problem-solving methodology, where you gather teams together and use the team to address the process. We have visual management, where the process is designed that you don't have to stress yourself. We have put markings, colors, identifications to ensure that everybody can get it right the first time without stress. Then we have the PDCA cycle, which is key in lean and would also be explained in the next slide. So you see a lot of these tools here. Understanding and using these tools are some of the things that drives lean improvement in your process. So let's look at the PDCA cycle. The PDCA cycle methodology is what helps continuous improvement. So the PDCA cycle, the P there is plan, do, check, and act. In some system, you use plan, do, check, and adjust, because at the part where you're checking, you have seen that in the process, there are some things you need to adjust before you go on the cycle again. So first, you are defining the case, you're checking. In planning phase helps you determine, why am I doing this? Why do we want to do this? What's the reason? What's the explanation of the situation? What goal do I intend to achieve? Then do is you doing the analysis, root cause analysis, 5 why, this is not, trying to identify why this problem, why do I have this problem? And then in doing, you have identified why the problem, and you have started implementing the actions you've called out. In check, you start seeing this action I called out, I said this contributes 5%. After implementing the action, did I gain that 5%? Oh, this contributes 20% to my loss. After doing the action, when I check, am I seeing that 20% improvement? Then act or adjust, like I said earlier, is looking at, okay, now that we have found out that this is a problem, now that we have been able to achieve this, how are we standardizing it? Sometimes in act, you have what we call horizontal deployment. I have done it on this process and it worked. Can I pick the learnings and move it straight into another process to replicate it without stressing myself? So it's also looking at best practice sharing. Under act and adjust, you see best practice sharing. So if you see major companies have systems that they have defined or described to use to share best practice. This project you have done here, this improvement you have had here, share it on the best practice page so that somebody from another facility can look at it and pick the result and implement directly. So the PDCA cycle is a continuous cycle that drives improvement. Because after this acting or adjusting, you look at the next place to attack, and then you go into it to get the waste eliminated. Now, Six Sigma. So yeah, from here forth, I'm going to be talking a lot on Six Sigma. We have two processes that we use in Six Sigma. Six Sigma basically uses the DMAIC model. I'm sure many of us may have heard about the DMAIC model and be wondering, okay, so what exactly, or what is it about the DMAIC process? So it's simple. It's just an acronym for define, measure, analyze, improve, and control. So in equipment design, you have a slightly different modification of the DMAIC process, which is the DMADV process. That's define, measure, analyze, design, and verify. So engineering equipment design process actually uses the DMADV model. But DMAIC is the main tool used by Six Sigma for process improvement. If you see this chart on the right, where you would see we have the CPOC process called down. Now, what's the CPOC process? We are looking at supplier, input, process, output, and customer. This defines a whole end-to-end operation. Don't forget that sometimes, especially in big industry, the customer in one end would be the supplier for another process. So the process, so it's linked. And usually what you have is the Six Sigma methodology by Deming focus on the process. So you bring out the process and split it into the different steps. And it is in these steps of the process that you start seeing opportunity for improvement and opportunity to reduce variation, eliminate wastages, and then add value to the system. Now, so this is where we tackle in Six Sigma. So just by way of additional definition, Six Sigma is a practice to systematically improve process to eliminate defects by employing a methodology to define, measure, analyze, improve, and control. Six Sigma also increases your process output to as high as 99.999966%. Usually you look like it's almost saying that if you are able to drive your system to a Six Sigma, you are almost achieving perfection. Because for every 1 million output you have, the probability, the defect you would experience is 3.4. And that's where the next line comes in. Because if a company is running at Six Sigma, long-time data will show that you have just 3.4 defect per million opportunity. DPMO is defect per million opportunity. So if you're having 3.4 DPMO on a system that is defined to be on Six Sigma, popularly, most companies or most process try to use 3 Sigma. And that's what we see commonly in the SPC graphs, which I would show us much later. In the graph, you would see, if you see this table on my right, it's telling you if you're operating at this Sigma level, what defect are you expecting? And what is the associated cost of quality? At 2 Sigma, we are discussing about 308,000 defects out of 1 million opportunity, which is massive. Most companies operate between 3 to 4. In 3 Sigma is when you have 1.0, but most companies operate at a target of 4 Sigma, where your process CPK is at 1.33. Now, we'll be looking at that later. So you have most companies, you see, that's the industry average, where out of 1 million, you have a defect of about 6.21. But at 5 and 6 Sigma, at 6 Sigma level, you are talking about just 3.4% in defect. Someone would ask, is it possible? In fact, I was discussing, and we're discussing, and we're like, well, is it even possible to achieve 6 Sigma? If you have that question, just think about it. if I'm manufacturing an aircraft, at what sigma level do you think I should operate? So if I'm manufacturing in the pharmaceutical industry, for instance, what sigma level would you expect of an industry with such high level that requires such high level precision? So you see that Six Sigma is a reality in some industry. So that's what it shows in those systems. The level of defect is so low that the impact on sales or cost of quality is less than 1%. Now, what is statistical process control? I've been mentioning SPC, statistical process control, since, and you would see that it keeps coming up when you're talking about Six Sigma. And that's because statistical process control it provides you the statistical method to observe your system. It helps you to predict. It helps you to remove sources of variation. So when you conduct a capability analysis on your process, on your department, on your especially if you are running a startup company, for instance, on the process you use for your system, when you conduct a capability analysis, it will help you know whether you can meet, or whether the product, whether it is likely that the product will not meet, that is not measured, or we meet specification. So you do a capability analysis. Okay, if my system has this kind of capability, will my product meet specification? And this is critical because it helps your competitive advantage. It drives competitive advantage. If I have two different suppliers supplying me with supplying input to my process, any supplier that gives me high level of variation, I would see it, because my process would show me that I am having a source of variation. And so I would rather go with a supplier whose system is able to give me product that are exactly on my own specification. This is where customer focus that we mentioned comes into play. So from an SPC point of view, a process is in control if the process is stable or predictable. And that is the goal. The goal of every process is to be able to say that every time I put 2 cups of rice, 2 cups of water, 3 tablespoons full of salt, half slice of onions, 3 cups of pepper in my process, I will get jollof rice. Every time I do it and I use the particular component, my jollof rice will taste this way. So for those of us for people that eat out, you would find out that you have a particular place where you go, and almost all of the time everything tastes the same almost, and you're wondering, sometimes it's because they have been able to define the input in the process. So it is stable, it's predictable. You can predict the process. If you notice, I'm trying so hard, I'm really not using manufacturing examples because I want us to try and see the facts, like we explained earlier, that this can be applied to any and every process. However, after putting in the work to get a process in control, how do you make sure it stays in control? I have gotten the process in control. What am I going to do to ensure that it's always in control? It is by eliminating or understanding your sources of variation. Every process has variation. Some variation, you know it, some you don't know, some are little, some are major. And so Dr. Schwartz helps us to identify two sources of process variation. We have what we call the common cause. Now, a common cause variation is a variation that is inherent in the process. Over time, as the process, depending on where you are doing it, depending on how you're doing it, they would be there. Usually, you see them, the variation on the system. If you see this control chart, for instance, you see the common causes being kept between the green zone. What that means is that the maximum variation you can get from a common cause would be within your control limits. You would even have planned your control limit with them. So they usually occur maybe due to wear and tear. As the equipment begins to run, wear and tear. So why we call them common cause is because when they start affecting the process, they are predictable. They are almost predictable. But when you have special cause are outside the normal process. You are running a process and there is an error by the operator. A part breaks suddenly. For instance, this particular webinar, if power should go off on either my hand or your hand, you would have a variation in how you're enjoying it. And that's a special course. So special courses are, they come suddenly and they increase widely your variation. In statistics, we refer to them as ROG. You see, they're called statistical ROG or outliers. They are outliers. You see a data that is giving you 234, 231, 234, 231. All of a sudden, you see 10, you see 15. Then you know that a special course has occurred around that point. Here again, I have the normal curve distribution explaining the sigma process. I'll start with the graph on my right. That's the colored graph. This is a common and popular graph we see when doing statistical process control. Now, the line, the center line that measures the peak, between the peak of the curve and the x-axis, gives you the mean. That's, you can call it, sometimes called the process mean. It's the target. You see, any deviation, any variation between 1 sigma plus or minus 1 sigma to the left and to the right, you see, let me see if I can point on this. You see, it gives you 68.2% within target. But if you are operating on 2 sigma, which is between plus or minus 2 sigma, you see a 95.4%. This is a massive jump. And then between 95.4 also, if we move on to 3 sigma, you have 99.7% probability of not having a defect. So your defect probability is 100 minus 99.7. Low. That's why we said DPMO for 3 sigma. You saw it was, I think, about 6,000. Now, if you go to the graph on my left, this explains further. It goes on to include 4 sigma. That's the 1.33 CPK level most companies use, between 3 and 4 sigma, where you have 99.9937. But you can see that as you move towards 6 sigma, you move towards a system that your output is completely, the probability of having a defect in your process is completely tending towards 0. So as you increase in sigma, the probability of defect tends towards 0. So for instance, you would, of course, that would mean that if I have 7 or 8 sigma, I would expect that these numbers or the probability of defect also becomes so low that it's almost impossible. This is what statistical process control helps you to determine. You are able to determine the deviation of your system process variations. And so in SPC, we have 2 different matrices that we use in statistical process control. And by the way, SPC is a full-blown course on its own that I think you can just look for. Bena also offers, I think, a class on SPC. So it's, for more knowledge, you can just reach out and for the full SPC course. Now, in process capability, we have 2 metrics. We have the capability index and the performance index. Both of them have a form of potential and actual. So in capability index, I'm saying what's the capability, how capable is my system to deliver on target? How capable is it? It's measuring common causes. I have these causes, so how capable am I to give the target even though I have these common causes? So you have CP, which is measuring precision. It's telling you this is what the system, the process is capable of. Then you have another metric, which is the CPK, which measures both precision and accuracy. Okay, so just to look at a little bit, okay, difference between precision and accuracy. If you are throwing a dart and you're on a dartboard, and every time you throw the dart, it will hit the same spot. You throw it 4 times, almost all the 4 times is around the same spot, but it is not on target. You are very precise, but you are not accurate. So you are able to hit the same, almost the same spot, so close together, but they are not on target, so you are not accurate. So you see, so that's why capability is measuring precision. But CPK measures your capability in line with meeting the target. It includes the target to it. So it means that if I am capable of delivering the target, then I am both precise and accurate. So how often do I always hit the target is a measure of accuracy. For process performance also has the same component. So in process performance, this is looking both at your common courses and special courses. So it's looking at all the form of variations coming into the system as you are operating. So you are looking also at the potential and the actual. Potential giving you a measure of precision, while the actual gives you the measure of both precision and accuracy. The only difference between the PP and the K, anytime you see the K is actually saying that we have brought the target into the whole conversation, and as a result, we are now measuring how close or how much or how efficiently you are meeting the target. So that's why we say it's precision plus accuracy. So to the crux of the matter, just to run through this, I'll be running us through the 9 module for competency assessment for Six Sigma. And this is fully reviewed at a 10-day masterclass at Ben IM&R. And so you can just, if interested, you can reach the right contact and get that. Now, let me call out that usually to attain a Six Sigma Black Belt, you have to write a certification exam, which is administered by ASQ. And the key, one of the key components, like we'll see later, is the ability to understand what is being measured or what competency is being assessed. I must also add that ASQ will tell you that achieving an ASQ certification is a measure of competency. So it's not saying, oh, this person is, no, we're saying, is this person competent enough to deliver or administer or act or execute Six Sigma? So that is a measure of competency, meaning that you must pass, you must show competency in all the pillars. In fact, we have seen people with great scores, but missing out on one pillar. ASQ would not certify you, because what they want to say is that you have an end-to-end competency. And so that's critical. And if you see, we have this different Sigma belt layers. So you see a white belt, that's someone with basic introductory knowledge on problem solving. You usually have them join problem solving teams with little tasks or roles assigned. Then you have yellow belt. I think I know that some yellow and green belts are also even registered for this session. So you have yellow belt. This person participates as a project team member. So he's also able to review process improvement and while working in an improvement team. And usually the expectation is that almost everyone directly related with the process should be minimum of a yellow belt. Then you have a green belt. Green belt are able to lead green belt project. And they also, as you get towards green belt, the level of proficiency in statistics improves, because at this point you have to be able to assist with data analysis, data collection, especially for projects that are black belt. And for black belt, which is where we'll be looking at, you see, it's you are able to lead problem-solving projects. In fact, as one of the competency you must actually display to ASQ before you can be allowed to write the certification is to show that you have actually conducted black belt projects. So, and this also, a black belt is also able to train and coach a project team. So usually what you have is you have a black belt working with multiple improvement teams, each team either led or directed by a green belt. So that's actually the role of the black belt. And then we have the peak. which is Master Black Belt. This is this trains and coaches Black Belt. It's usually a peer-reviewed certification. In fact, before you can even be allowed to write the competency test, there is a deep review of the body of work you have been involved in and the years of experience in which you have had this body of work before you can actually apply and write a Master Black Belt certification. So, yeah, just like I called out earlier, over the next few minutes, I'll be looking at each module and I'll be sharing the competency or the competency it is expected you display for each of the pillars of Six Sigma Black Belt. And the first module we're looking at is organizational-wide planning and deployment. First, a Black Belt is expected to understand how to deploy Six Sigma within a project. So this is going to be looking at your ability to, implement the tools. You would be measured to see if you even know the fundamentals of Six Sigma and Lean methodologies, which is why we have to take a session on that first. We'll also be looking at your understanding of the use of Lean and continuous improvement tools, how you are able to use Lean initiative, how you are able to screen projects to know which project should should be conducted or not. Because if you don't you will be entering every project and then you will find out at the end of the project that you have actually even contributed to a waste in the system because the impact of the project is not enough, enough to override the resources you have used. So you'll also be able to apply operational change. So we want to see that this person can apply operational change. We also want to see your leadership. They'll be measuring the leadership of project leadership. We're measuring your ability to know organizational roadblocks. Okay, does this person know how to bypass the organizational roadblock when it comes to implementing a Six Sigma project? We'll also be looking at your ability to understand, like I explained earlier, both common courses and special courses. Understand which is which when running and driving the Six Sigma project. So this is the competency that is tested in this model. And so there's a little bit of understanding Lean history, Six Sigma history. So if you are able to display this competency, you would not have a problem with this model when writing a Six Sigma Black Belt certification. Now, the second module is looking at process management and measures. If you are going to implement a Six Sigma project, we want to be sure that you can know the impact. What you can know, why would I go into this project? What are the management measures that I need to look at? You expect that you know what benchmarking is. What's benchmarking? How do I benchmark my company against a company? How do I benchmark my company versus industry's average or industry standard? How do I benchmark my process, what I am doing now versus a better one? Okay, pick for example, I would use a dry cleaning process. So I'm avoiding the manufacturing. I'm a dry cleaner, and then it takes me this long to finish ironing a shirt, fold it, and package it for the customer. So, but I have a dry cleaner also beside me that does that in half the time. How is he able to do it in half the time? Maybe he has implemented some tools, implemented some processes that I don't know. So benchmarking helps you compare the two and see the two processes to see what improvement you can have on yours. So that's like the basic, a simple way of actually putting it. So you'll be looking at best practice. You should be able to select measures and performance goals for projects as a result of your benchmarking. Then secondly, we expect that you'll be able to describe the various types of performance measures. What would I be using to measure this project? Whether it's performance or financial. So I'm going to be checking the key performance indicators. What KPIs am I using to check? What KPIs, what KBIs am I looking? Okay, you have to be able to understand the KPIs. What are my leading indicators? What are my lagging indicators? Your understanding of that is also going to be tested. Then financial measures is also critical. You cannot do the goal. I think I skipped mentioning this, but I need to mention it now because ASQ will mention it over and over again. The goal of every Six Sigma project is cost reduction. We want to see the financial number most time. For a Six Sigma project, what's the financial numbers you are attaching to it? So are you looking at a net present value? Are you looking at return on investment? Are you doing a cost benefit analysis to show us that this project needs to go on? Because it is as a result of all of this analysis that we would be able to say, okay, let's go ahead with this project. Is what the resources? Let's go ahead with so a Six Sigma black belt is expected to be able to deliver this effectively. Module 3 is team management. This usually seems to be one that I like a lot because the success of every Six Sigma project is the team. And so a Six Sigma black belt would be expected to be able to constitute teams. You must be able to do team formation. So you're able to define and give roles to each team. You need to also know which type of team will I be using for this project. You also be able to assign team roles and responsibility. Clearly, it's important. What role is this person doing in this team? Who is the facilitator? Who is the leader? Who is a coach in the team? Who will just be members? You must be able to address frictions in team. You must understand the different process of team formation. So, we have the forming stage, the storming stage, the norming stage, all the different stages of team formation. You must have key understanding of those stages to be able to come in and implement whatever address that you need to address anytime the team is derailing from the set goal. And you must also be able to say what are the factors what are the elements that we can say that will result in a team success. So you must have team success factors. You must have management be able to define the level of management support required. You must be able to define the ground rules. In this team, this is the ground rules. Timeliness. What are we using timeliness? What happens if we don't get this done by now? It has to be clear. Then the success factor must be clear. Then you must be able to facilitate teams, motivate teams. Sometimes the teams, sometimes you're running a Six Sigma project. There's some Six Sigma project that they're like golden. You start it, we get into the numbers, you start looking at the root cause analysis. After the brainstorming session and root cause analysis session, you start addressing it and the results start coming. Those ones are so cool. At that point, everybody is on top of the world. The teams are enjoying. But then you hit another Six Sigma project where you get to a point where the team are beginning to lose motivation. You must be able to know what is causing this motivation loss. What can I do to improve and bring the team back into track? So this has to be clear. You have to be able to demonstrate competency in this. Like I mentioned earlier, what you will be tested, the questions will be testing your competency. So there is this myth that you can't pass the Six Sigma black belt once. I've had a lot of people that say, okay, wrote once, twice before they're able to get it. See, if you are able to develop this competency, either physically and by doing, you would be able to have an easy way in it. Now, module 4 is define. You must be able to define this is where the DMAIC process comes in. So in D, we are looking at define. You must be able to know customer data to collect, understand your customer. Then you must know customer requirements. In this place, you see customer requirements coming, things like critical to quality, quality function deployment. You must be able to understand CPOC process effectively, and you must be able to know all of this critical to quality tree. All of this understanding would help you in defining. So this helps you define the project. And then you must understand project charter. Project charter, in fact, is one key thing you must be able to say, okay, the project, this is what the problem statement, this is our scope, this is the goal, and you must be able to use it to track the project progress. So understanding the project charter and being able to use it to track the progress is also critical. Measure is divided into two. I should mention, under measure, there are two competencies that is being measured. You have the data management competency and statistics. Let me say clearly, ASQ is the success of any ASQ certification is statistics. In fact, statistics component of ASQ certification is I don't want to scare you, but like the major place you need to focus on. Usually, even for me personally, was at the master class having two deep statistic professors and do statistics that helped me demystify some of these things. So in measure, you would see data analysis, your ability to be able to say, okay, what's the process flow? What are we looking at? What's the takt time? Calculating takt time, checking throughput yield, you know, understanding your process metrics, constructing process flow maps, spaghetti diagrams to understand where losses are. You know, all of those are, you must be able to do it in measure, because these are where this is understanding of this will help you come out with clear actions, because if you're able to do data management and deep dive using these data tools effectively, you would have a successful project, because you would be able to reach the crux of the matter, where if you solve, you would get an outcome that is expected for the project. That's where data management comes in. And okay, and you have the second aspect, which is statistics. You must use that must using the capital letter MUST. Understand statistics, basic statistics, intermediate statistics. I think it's just between basic, intermediate, although there's some little level of advanced statistics. So you must be able to know statistical measures like correlation, regression analysis, multivariate tools, hypothesis testing, using analysis of variance, and the rest. You must be able to understand each of those tools, because some of those tools are so similar that if you're not careful, you would mix it out. So your core understanding of statistics, because statistics, even questions in statistics usually tie into other questions. And as a result, if you don't understand the basis, it will be a little bit difficult to address or to get those questions well. Then we have analyze. Analysis is a part that I enjoy a lot. Is where you finally are doing the FMEA root cause, using the root cause analysis tools. It is in analyze, you start using some of the tools, okay, linear regression, FMEA, you know, you do hypothesis testing also sometimes, and then in analyze also, you are checking what sample size you are using. Many of all of these things, and analyze also, I must say, also has a big chunk of statistics also, where you have to actually focus on waste analysis. Where are the wastes coming from? Root cause analysis is critical at this point. Here you are looking at your 5Y. How am I able to do Pareto charts? Because in running improvement projects, really, Pareto is the biggest, because you must be able to see the 80% that I can take out by just doing the 20%. I'm having all of this gap. Which action will I take that will give me 80%? And so I can just forget about the 20%, and the improvement will be clear. So that's also comes under analyze. Then improve. Improve. You must be able to show that you understand and you can apply design of experiment. This design of experiment, just to put it simply, is you setting or changing the conditions of a process to check the output. So you keep some part of the process constant while you tweak some to see where the source of variation is coming from. So you must be able to do design of experiment, know the different types of experiment that you'll be conducting. Then you must be able to apply all various lean tools and techniques to eliminate waste. Now, see where improve comes under Six Sigma, yet we are talking about lean tools. So you see why we mentioned that your foundation of Lean must be strong if you are going to run Six Sigma. So you must be able to use those tools to eliminate waste and reduce the cycle time. And in using those tools, you know, the questions will try and test your core knowledge, your applicational knowledge, SMED, JOKA, and cycle time, continuous flow, all that would be tested. Then Kaizen, you must also understand how to use Kaizen, Kaizen Blitz, and when you need to use each of these tools. Let me mention that knowing the tools and knowing when to use them, knowing when to use the tools is almost as important, if not more, than knowing the tools. So you must not only know the tools you want to use, you must also know when you want to use them. Then you should be able to implement implement an improved process and analyze and interpret all the risk associated. That's module 7. Module 8 looks at control. And this is where SPC comes in. SPC, total productive maintenance, visual factory. Yeah, SPC, yeah, in control, if you go into the core of SPC, you see that SPC helps you know when do I need to come into the system. So because you are running an SPC, say for instance that you have a control chart and you are checking the variation in your output. As you are checking the variation, you see a sudden variation that you cannot explain. You know when to come in. So you must be able to analyze and use statistical process control techniques, SPC in control. And then you must also be able to look at actions and what you would do, controls that would ensure that all the improvements you've gotten are sustained. So usually we will see visual controls. This is where you have visual controls, color coding, indicator light, picture of how the perfect system should look like. All of these would be done under control. And I think the last module is a short one, and this designed for Six Sigma. You would be expected to know what the design for Six Sigma methodologies are. So for instance, you should be able to identify and describe DMADV. Even though you are not using DMADV, you should be able to describe it. You should be able to also look at other tools like DMADOV, like which is define, measure, analyze, design, optimize, and validate. You need to understand these tools. Then there is also design for X, where you are looking at design constraints, or you are, okay, if I'm designing, what am I designing for? Am I designing to test? Am I designing for manufacturability? Am I designing for maintainability? This one is more common with the engineering, where you're looking at, so the design for X is that, okay, what I'm designing, the X there is the unknown. So you pick the unknown. What do I want to design for? And then you must also be able to understand the concept of robust design. What if I'm doing robust product design, what do I need to focus on? What are my tolerance? What is the statistical tolerance here I need to look at? So those competency is what is going to be tested at the ASQ Six Sigma Black Belt. Now, like I said, what I have tried doing in the last 20 minutes is a 10-day masterclass BoK review at Bainer. So you see that it's not something that you can exhaust in a short session. This is just to give us like a teaser and a framework of what is expected. That's why it's called the roadmap review. Okay. In conclusion, I would just like to give us some tips. What tips? Are you into continuous improvement? Are you a production manager, production engineer, continuous improvement specialist, or are you looking to attain a ASQ Six Sigma Black Belt certification? I've called out some tips basically from my own personal experience. Let me say, out of the myth, away from the myth of you can't pass it once, I wrote the exam once. At the end, I finished the masterclass on Friday and wrote the exam on a Saturday and passed once. And actually, I think when I did, I was the only certified black belt in Nigeria for the month of the exam. for the particular session when I did. And so I am calling out because I saw some of the things that helped, and that's what I'll be calling out first. One problem we usually have with people trying to get a Six Sigma black belt is you don't have any experience in continuous improvement and you want to write a black belt. If you're planning it as a career path, get involved, garner the experience. It's a test of competence. I've been saying this. And what is going to test is your practical understanding of the tools. So if you have the opportunity, maybe you're working as a production operator, volunteer when you see that your line, they want to do a production Six Sigma project on your line, volunteer, either as a yellow belt or a green belt. Volunteer. If the opportunity comes for you to take up and lead the project, take it up. Take advantage of these little opportunities. I had the opportunity to take up little project, lead this, lead that, and that was one of the things I think was a major factor that helped. The second step is to start preparation early. See, not passing the exam, like I said, is a myth. If you start early and you prepare well, you have the high probability of passing is there. So you have to decide when you are writing and start preparation in earnest. These are not certifications you just wake up and say, hey, I want to write this thing tomorrow. No, because this is a test of your competency. So you need to be able to combine both your mental competency with your physical, practical competencies together to ensure that you are well poised to get the certification on the first try. Third tip is get relevant materials. Get relevant materials. I used to have some pictures of my table when reading containing different big books. It's not really about the big books. You know, initially I was focused on the big books until I found out that until I got from BAINA, the Quality Council of Indiana BoK manual. You see, you need to note what the manual that can address directly the certification you're going for. So get the BoK, excuse me, polish areas where your line of work may not give you direct experience. This is critical. You are in a pharmaceutical industry, or you are in an industry where maybe you are not privileged to do some other aspects. You need to get into it and read. That's the thing, because some people may be privileged to be exposed end to end to all these tools. All these tools are not applicable across all. So you need to know which one is applicable in your industry, which one is not, and how you can get the knowledge from the ones that are not applicable in your direct line of work. Immediately you register for the masterclass with BAINA, you get a copy of the QCI BoK. So that makes it a little bit easier for you to address the material issue. Practice, practice, practice. Practice loads of past questions. Practice. You know, you think you know it until you see the twist on the technicality of the question. I like to use the word demystify, because when you see that these questions, you see a question that you actually know the answer, but because it's technically, it's testing a level of technicality, you have some issues answering it. So get familiar with the question. Get familiar. There is about 2,000. I had about 2,000 past questions with me available for me, so it was easy to try and try. Second to the last tip is attend a master class. If you can, attend it. You meet people that are preparing for the same exam. For instance, it was during my master class that I know that I found out that because it's an open book exam, when I was reading, I should have been using sticker notes to call out key points and stick at different points in the book. Until I got to the BoK master class and saw, especially because my master class was next door to the CRE guys. Those guys are very good guys. And you know, I just saw that, oh, I've just been reading all these. I was not bookmarking. So I learned bookmarking at that point, and the 2 weeks was enough for me to quickly close up on the gaps. And it made it easier in the exam when I needed to reference some document to be able to see where I need to check. So the exam are not exactly difficult. That's my point. I think they are actually just tricky. So if you have been able to demystify and understand the technique for answering, it becomes easy. Then tip 6 is be confident. Be confident. See, what we want to test is whether you are competent or not. And you know you are competent. If not, you won't be attempting to write the exam. So Be confident that you are competent. Confidence helps you. Then, like I just put here, get a malam to keep ringing it to your head. Get people to ring it in your head. I had my family and friends that knew that when I told them about the exam and how tough the challenge was, they were telling me, "Guy, you go pass." Honestly, I wish I was as confident as they were. You know, sometimes I would say, "Malam, I don't understand this part," and it's like, "Baba, you see, go, you will pass." And the confidence level keeps rising. So if you're confident, it helps you to be able to, you know, get and arrange the resources that you have already put into your head, the knowledge you have, the experience you have. So it helps you to be able to call on them when you are in the exam. And the last one that I didn't put here, I do it in every exam. Carry sugar, always have sugar with you. Your brain uses sugar. So anytime you are preparing or writing any exam, you need to have sugar with you. A bottle of Coke, a bottle of, you know, anything that contains sugar, and take a lot of sugar. Your brain would use it. Don't worry, your blood sugar level will not increase. I think that's the light side. Thank you very much. Thanks for registering. Thanks for attending. Thanks for listening. Malam.
Thank you. Thank you, Dio. Thank you, Dio. As expected, you did excellently well. If we had the opportunity, I would have asked the house to give you a sound clap, you know, but unfortunately, we cannot do that. Wonderful, wonderful. Brilliant takeaways from Dio's session. I have seen many people have already been asking questions about how they can implement, and those who before now had no single idea about Six Sigma, how they can start, and all that. But by summary will be that for those of you who have had some reasonable experience and who have been working in an environment where there is a need for continuous improvement, if you have not been doing Kaizen, for example, in your business, you can start with what Dio called Kaizen Blitz. Kaizen Blitz is an iterative Kaizen project type that the basic thing about Kaizen Blitz is that it is short. It is a project of few days, between 2 to 5 days. You quickly implement it, gain the improvement that you want in a section of your process, and then move to another section, do another blitz like that. So you can actually start with little Kaizens like that are called blitz. There is a process to it. Somebody has already asked that as well. There is a process to implementing Kaizen. We can always guide you. You don't worry, you will not have to pay for it. We can guide you. At least for the beginning, we will guide you and give you some coaching and sessions to help you develop yourself. And like Dio also mentioned this, and I always say this in my classes whenever I have to stand before people to talk about improvement projects. You will never really be sustainably successful in your Six Sigma project if you do not do lean. Lean, you must understand, would lead you to great success in your Six Sigma. So things like 5S are very important to your Six Sigma process. You cannot be doing Six Sigma projects on your process or your assets where the assets and the work area, they are very untidy and dirty, for example. You need to put everything in its place before you can be able to do well with your Six Sigma. Otherwise, all the things that Tijani and Dio have talked about, waste. One of them is waste of time in time, spaghetti. Because the work area is untidy, you waste a lot of time walking about when you can just simply move from A to B as the crow flies. If you know the bird crow, the bird crow moves only in straight lines. It doesn't have too much energy. It will rest, but when it takes off, it goes straight. And it identifies the shortest distance between point A and point B and goes there. So as the crow flies is what you are supposed to do. Do not also forget that the PDCA cycle that you talked about, the DMAIC cycle, it's very important. It is a guide to everything that you will do in your lean or Six Sigma or any project, in fact, or any project, you know, everything should follow that cyclic guide of plan. You do, you check, and then you act if you need to act, or you end it if you need to end it. Again, in summary, Dio also mentioned that SPC is a foundational part of Six Sigma. My dears, if you do not have a full understanding of SPC, you are unlikely to make any reasonable headway in any Six Sigma project. So you must start with SPC and have a great understanding about what SPC is about. SPC typically uses the 3 sigma normal distribution. That is 3 sigma to the left, 3 sigma to the right. And then absolute will be 12, will be 6 sigma absolute. Whereas 6 sigma uses 6 sigma to the left, 6 sigma to the right, and then absolute 12 sigma. So please try to understudy SPC very well. Like Dio also mentioned, we have a course specifically on SPC, and so those who are in any form of operations, it doesn't have to be oil and gas, it doesn't have to be manufacturing, any industry, as long as you are in operations management, you know, where you measure quality, then things like SPC will be very important to you. So you can do this. We have a course, full-blown course on SPC. And then I would like to mention again that the second to the last slide of where he mentioned DFX, design for X. X there represents many different things, as he mentioned. So X can be 6 sigma, X can be maintenance, X can be manufacturing, X can be anything, testing. So it is designed for X, designed for manufacturing, designed for testing, designed for maintenance, designed for blah, 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 blah. That is what it is. And thank you, Dio, for reminding me of your statistics experience, all your experience during your masterclass. Next door to his class, during his time, we had the CRE guys. We were taking the courses together, side by side, the same 2 weeks. And he joined he joined the CRE guys for the statistics. It was very, very enlightening. In our team, we have some very brilliant guys who used to help us demystify statistics. If he's here, Kabbalah Usman is our greatest asset for statistics. The guy is a master in statistics. If you know him, Kabbalah, if you are here, raise your hand. Let them know you. If you know him, please, and you want to do any ASQ certification, CQE, CRE, CSSBB, anything that involves statistics, if you know him, begin to hold him from today. He's the main man. He leads us in statistics. Very wonderful guy. And then, of course, we have Gado and myself who come behind him. So thank you very much, gentlemen and ladies. Thank you. Now we will take.
Malam.
Yeah.
Yeah, sorry, I just saw a note from someone, so I needed to mention his name, Engineer Adiremi Adewoye. I forgot to mention, somebody asked me a question, and I think the answer is in me, seeing him. The first time I met him, one of the conversation I had with him was what pushed me to decide to get the Six Sigma Black Belt certification. So public thank you, Engineer. So for somebody already asked the question as why if I want to, what do I need to do? I think like I just shared now, you first start with the trigger to know that, okay, I think this is a line I want to do. And then you now start meeting the right persons, because Engineer Remy was also one of the person I met, and before the journey started. That was like 3 or 4 years ago. So
okay.
Just to mention.
Okay, thank you very much. And I would like to also thank Remy. He is present in the house. Thank you very much, Plan Manager, Director. We are grateful to you. So now We will try and answer some of the questions. While Dio was presenting, many questions came in, and I have tried to answer as many as I could, as my knowledge will allow me. I'm not that good. So all the ones I have answered, all of you will receive them when we are sending the video and the slides. You will also get a PDF file of question and answer. But there are some of them here. Maybe Dio can answer them. Let's see if there's still any more questions. Dio, let me check. Let me check for you. Nice presentation. That's for you, Dio. Somebody is thanking you.
I've also been answering some of the questions as posted on the Q&A, so
okay.
People can just look through. But maybe we can pick representative questions, because most of the questions have actually been answered.
Okay,
yeah.
I'm looking for a new one. The rest are what I'm seeing here are pretty easy. Do you offer virtual classes to people outside Nigeria? That will be yes. That will be yes. So how can one get experience in the modules that are not related to your field area of expertise? I will need additional explanation on this question. Dio, do you understand that?
How can one get experience in modules that are not related to your field areas? I think I mentioned this. For instance, in my area of work, I've never had to do DFSS.
Okay.
So you usually in getting, like I mentioned, there are two ways to it. One, first you need to get the knowledge, and then when you get the knowledge, you see YouTube is also has a lot of free resources. Also, you can see some videos of sessions where they have been able to use these tools. So that gives you, because what I have seen with almost all of those tools is that your understanding of the simple tools will help you understand the major tools. So when you get to the ones that look big, if you understand the simple tools, you would see that it's a combination of the different sections of the simple tools. So that's where I usually like to start. Start from the simple, and then when you get to the complex one, you would now be able to use the experience you have in the simple to execute.
Okay, thank you. No more questions. Okay, there's one I'm seeing now. That's probably for me. That's from Jawad Alasa. He said, Malam, can we please have a BoK review on ASQ CRE? Oh, yes. We are just starting. CSSBB is leading the way. We will do a BoK review later on CMRP, on CMRT, on CQE, on CRE, all of them. We will do a BoK review as time matures. So don't worry, many more will come to you. Many more will come to you. No more questions. Thank you very much, Dio. Thank you, everybody who has asked the question. If you have any additional questions, you can ask. You can drop them here, or you can send us a private email by WhatsApp, anything, and then we'll try and answer them and send back to everybody. Now, let's go to the next slide, which that's Q&A. We have just finished that, and the next will be here. Now, but before we go to the polls, again, I would like to reintroduce our special practical leadership essential course that we have advertised the last week, when we treated leadership. For those of you who have attended our webinars, we will require for you to earn the 100,000 Naira discounted fee for the 2-day session. We will require you to have attended at least 2 of our past 3 webinars, this one inclusive. So for you to earn that 100,000 Naira discount, you should have attended at least 2 of the 3 webinars we have had. Only then will you have the chance to earn this 100,000 Naira fee. Otherwise, the other people will have to pay still a discounted fee of 130,000 Naira. The original fee is 180,000 Naira, and we'll see to it that we give some free seats, as many as we can. But we will we will consider the persons that we will give the free seats, unfortunately. We will give to those who need. So it is open now. Anybody who is interested in the this leadership course at 100,000 Naira, who has attended at least 2 of our sessions, please, in the chat box, you can just write there, I am interested, and our business development people will follow you up in the future, from now, in the future. Okay, and then we will share with you the course content. You will see the course content, full-blown course content as well. Ask from our business development people, and they will show you. So our next webinar will be on the 30th of May at 2 o'clock, same time, and it will be run by Engineer Sheyi Iwaeni, Nigeria's first and only CMRT. He is the first and only certified maintenance and reliability technician. So, and he is also our trainer with myself for CMRT. He is going to be handling the next webinar topic, which is dealing with maintenance budget cuts after a time like this. And it is a looming monster. It is definitely a looming monster. As companies are beginning to open gradually, one of the things critical to them is how can they make themselves survive for the balance of the year. And one of the things that they would like to do is to cut your maintenance budgets. It's understandable, but what we will be dealing with during this session will be how can you help yourself and help your business prevent yourself, first of all, from having your budgets cut, but there are conditions to it. If you have made your budget correctly previously, then it will be a bit easier for you to defend your budgets. But even if you have your budgets cut, how can you still help your business to save some money? So that webinar will come in 3 modules. One, we will introduce you to the business of engineering finance and budgeting. So we'll talk about budgeting, and we'll explain the different types of budgeting to you, and then we will tell you what our idea is as the ideal type of budget that you should be doing, some of which we have been doing. I have personally been doing for more than 15 years in my career. I have been doing a particular type of budget, and I can tell you that it has worked extremely well for me. You have peace of mind. And the last budget that I made before I retired, I got approval of more than $500 million for training alone. More than $500 million for training alone, manufacturing, but manufacturing capability alone, $500 million. And it is this technique that I used. Very easy to defend it. Very easy to defend it. And then, of course, we will introduce you again to maintenance, the different types of maintenance, and will help you to have additional understanding before we now go to the 3rd module, which will be giving you the practical tips as to how to help your company to save money as much as you can. So that will be Saturday, 30th of May at 2 p.m. On this same platform. That will be our first paid webinar. It is going to be charged at 20,000 Naira. So anybody from today, registration will be open, and our business development people will begin to talk with you. So if anybody is interested also in this maintenance budget webinar for 30th of May, you can also write in the Q&A or the chat pane, write it there that you are interested, and our people will get back to you. It is going to be 20,000 Naira. It is going to be 20,000 Naira. Thank you very much. Okay. Now we will go to our polls. We have just a few questions, the same kind of questions we have been asking before, but we are bringing them again because we realize, we recognize that it is not everybody who was in the last session that will also be here. So for those who were not in the last session who are here, we give them an opportunity to answer the polls questions again. So I will I will allow the panelists to also answer. So I will launch the first poll. Okay, please answer. It is open. If you can see the poll, please begin to answer. Begin to answer. More people, please. 30 people only have answered. We have up to 150 people online. More people should answer, please. Some people are raising their hands. Whatever your questions or whatever your concerns are, please drop them in the chat or in the chat pane, so that you cannot see the poll. Really? Somebody said he cannot see the poll. Dio, can you see the poll? Dio is not there. Gado.
I can. I've answered already.
Okay.
I can.
Okay. So somebody said he cannot see the poll. Maybe it's from his system. Okay, I will end the poll now in 5 seconds. 5, 4, 3, 2, 1, 0. Okay. I have projected the results. So for this question, the overwhelming majority of the people say it is a fair price, $50 for the next webinar. Thank you very much. We'll analyze this. The next poll will be, where is it? Okay, the next poll will be this, the same usual poll that some of you have seen before, but please answer again. It is for research purpose. It is for research purpose. Please answer. All right, I will stop now. I will stop you now. 5, 4, 3, 2, 1, 0. Some people are still saying they cannot see the poll. I don't know why. I don't know why. I will share the results, and I hope you can see the results. I have shared the results now. And can you see the results, Dio? Alamide?
Yes, I can. WhatsApp and LinkedIn again.
Okay, good. Okay, so once again, WhatsApp has proved to be the most effective form of communication to reach our target audience. Thank you very much for this vote. We appreciate you. The last poll will be, okay, freebie. Last poll. Answer, please. 20, 25 people have voted. More should vote, please. 50 people have voted. We have well over 100 people online. Vote, 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 please. Okay, I will stop you in 5 seconds. 5, 4, 3, 2, 1, 0. Thank you. I'm sharing the poll results again. Overwhelmingly. Okay, somebody's asking what is FCFS? First come, first serve. First come, first serve. First come, first serve. That's the meaning of FCSS, FS. Okay. So thank you. We'll analyze these results and make a decision. Thank you very much. That will be all for today. The next slide shows our contact details. You can contact us via email, telephone, voice, WhatsApp, or you visit our office. Our office is open every time to any one of you. If you want to come and chat with us in the office to see what facilities we have and how our office is properly set up for learning, you can please visit our office. We pride ourselves in having a very comfortable office. Thank you very much, gentlemen and ladies. We have come to the end of this webinar session. Thank you, Dio, for the wonderful presentation. We will urge you to come again to do another one for us again. Thank you, everybody, for coming.
Thank you for
if you have any questions, please send to us. Thank you and bye-bye.
Bye-bye. Have a great day.
Thank you, sir.